Gantry crane, working, design, and uses at dam sites. A gantry crane is a type of overhead crane with a bridge supported on legs that move on fixed rails or wheels. Unlike overhead cranes, which are supported by building structures or beams, gantry cranes are self-supporting and can operate independently on the ground. This makes them particularly suitable for outdoor applications or large-scale industrial settings where internal structural support is not feasible or cost-effective. At dam sites, gantry cranes play a vital role in both construction and long-term operation. They are used to lift, move, and position heavy components, such as spillway gates, turbine parts, generators, trash racks, and other essential mechanical structures. Because dams involve massive structures and high-capacity equipment, the use of gantry cranes is indispensable. Basic components of a gantry crane. The main components of a gantry crane include girder or bridge beam. This is the horizontal beam that spans the working area. It carries the trolley and hoist, and is usually fabricated from structural steel. Depending on the load capacity, it may be a single or double girder. Legs or support columns. The legs support the girder and transfer the load to the ground or rail system. The legs may be fixed or mobile. They are often designed to resist lateral loads due to wind or crane movement. End carriages and wheels. These are installed at the bottom of the legs and allow the entire crane structure to travel along rails or the floor. Heavy-duty wheels, sometimes with drive motors, are used to move the crane back and forth. Hoist and trolley system. The hoist is responsible for lifting and lowering the load, while the trolley carries the hoist along the length of the girder. The hoist is powered either electrically or hydraulically. Electrical system and controls. Modern gantry cranes are equipped with motorized controls, limit switches, sensors, and remote control systems. Variable frequency drives, VFDs, are often used for smooth acceleration and deceleration. Safety systems. Safety features include emergency brakes, overload protection, anti-collision devices, travel limit switches, and wind-locking mechanisms for outdoor installations. Working principle of gantry cranes. The working principle of a gantry crane revolves around a coordinated system of vertical and horizontal motion. The hoist mechanism lifts or lowers heavy loads vertically. The trolley moves horizontally along the girder, and the entire gantry structure can travel on rails or wheels, allowing motion in 3 directions: vertical, longitudinal, and lateral. For dam applications, precision is critical. Gantry cranes are often equipped with encoders, sensors, and automation systems to allow precise positioning of massive components. Some cranes also include synchronization features to control multiple hoists working together on a single load. Types of gantry cranes used at dam sites. Full gantry cranes. These cranes span the entire working area with 2 legs riding on rails. They are used for large-scale lifting tasks, such as placing concrete blocks, turbine assemblies, and dam gates. Semi-gantry cranes. These have one leg supported on the ground and the other attached to a wall or structure. They are used in areas with space constraints or where one side can be fixed. Mobile gantry cranes. These are smaller, more flexible cranes mounted on wheels. They are used for maintenance tasks or moving components in confined areas. Specialized gantry cranes. Dams often use custom-built gantry cranes, such as intake gate gantries, bulkhead gate gantries, and trash rack cleaning gantries. Each type is designed for specific tasks related to water regulation and maintenance. Uses of gantry cranes at dam sites. Handling and installation of spillway and intake gates. Spillway gates control the flow of water out of the dam. Gantry cranes are used to lift and position these gates during installation. They are also used for lifting gates during routine inspection or replacement. Turbine and generator assembly. Hydropower dams contain massive turbines and generators that must be installed with precision. Gantry cranes are used to position these components into place and also to lift them out for repairs. Trash rack and debris handling. Trash racks are metal screens used to prevent debris from entering the turbines. Gantry cranes equipped with special cleaning mechanisms are used to lift and clean these structures. Concrete placement and formwork handling. During the construction phase of a dam, gantry cranes handle large concrete blocks, reinforcing steel cages and formwork. Their lifting capacity and mobility make them ideal for placing materials exactly where needed. Bulkhead gate handling. Bulkhead gates are temporary barriers used to isolate sections of the dam or intake tunnels. Gantry cranes are used to insert or remove these gates, especially during maintenance shutdowns. Emergency maintenance operations. In emergency situations, such as equipment failure or structural inspection, gantry cranes enable quick access to critical components without the need for disassembly of surrounding structures. Design considerations for dam site gantry cranes. Load capacity. Cranes at dam sites are often required to handle extremely heavy loads, ranging from 50 to over 500 tons. The design must include a safety factor above the rated capacity to ensure structural integrity. Environmental conditions. Dams are often located in remote, rugged, or extreme environments. The crane must withstand high winds, water spray, freezing temperatures, and exposure to sunlight. Materials must be corrosion resistant, and electrical systems should be weatherproof. Structural support and foundations. The foundations for gantry cranes must be carefully designed to distribute the heavy loads. At dam sites, cranes are often installed on concrete runways or steel rails embedded in the dam structure itself. Wind locking mechanism. Due to the risk of strong winds, particularly on the dam crest, a wind locking system is essential to prevent the crane from moving or tipping during storms. These include rail clamps and anchor bolts. Control systems. Cranes at dam sites may be operated manually, remotely, or automatically. Modern control systems include programmable logic controllers, PLCs, human-machine interfaces, HMIs, and wireless remote systems for greater flexibility and safety. Redundancy and reliability. Because dam infrastructure is critical and downtime can result in significant economic and environmental consequences, gantry cranes must be highly reliable. Redundant braking, multiple motor drives, and backup power systems are often included. Safety and operational protocols. Regular inspections. Routine inspections are conducted to check for wearing cables, gears, motors, and structural components. Load tests are also performed periodically. Operator training. Crane operators at dam sites must be trained in both crane operation and site-specific procedures. They are also trained in emergency protocols and equipment handling. Emergency systems. Emergency stop buttons, sirens, lights, and interlock systems are included to shut down operations instantly in the event of a failure or hazard. Load monitoring and overload protection. Digital load indicators and overload sensors prevent the crane from attempting to lift beyond its capacity. Alarms notify operators if limits are exceeded. Fall protection and access safety. Platforms, railings, ladders, and harness anchor points are provided for safe access to crane components during maintenance. Maintenance of gantry cranes at dam sites. Preventive maintenance. A schedule is followed to check motor conditions, lubrication of moving parts, alignment of rails, and condition of electrical systems. Bearings, brakes, and hoists are also inspected. Corrective maintenance. When failures or faults are detected, parts are repaired or replaced immediately to minimize downtime. Corrosion control. Due to constant exposure to moisture, cranes are painted with anti-corrosive coatings, and structural parts are inspected for rust or deterioration. Hydraulic system maintenance. In cranes using hydraulic power, hoses, pumps, and fluid levels are regularly checked to prevent leaks or pressure drops. Electrical system checks. Panels, wiring, circuit breakers, and control units are checked for faults. Lightning protection systems are also included in many dam site installations. Examples of gantry crane use in real dam projects. Three Gorges Dam, China. This massive hydroelectric project uses large gantry cranes to manage turbine maintenance, gate operation, and mechanical equipment handling. The cranes are specially designed to handle loads over 300 tons. Bakra Dam, India. Gantry cranes are used to operate radial gates on the spillways and manage water flow. The cranes also assist in the maintenance of hydroelectric generators and intake structures. Advantages of gantry cranes at dam sites. High load capacity. They can lift and position extremely heavy and bulky loads with precision. Mobility and flexibility. Unlike fixed cranes, gantry cranes can move along large sections of the dam, covering a wide work area. Customizable design. Gantry cranes can be engineered to meet the specific needs of a dam, including the span, height, and load requirements. Efficient operation. Automated and remote-controlled systems allow for safe and efficient operation even in hazardous or remote conditions. Reduced downtime. By enabling quick access to critical components, they help reduce maintenance time and minimize operational interruptions. Challenges and limitations. Initial cost. The design, fabrication, and installation of heavy-duty gantry cranes require significant investment. Weather dependency. Outdoor gantry cranes may have limited operation during severe weather events, such as storms or heavy snowfall. Space requirements. Large gantry cranes require extensive clearance and foundation space for installation and operation. Maintenance complexity. Due to their complexity and high usage, regular maintenance is essential, which requires trained personnel and spare parts availability. Future trends in gantry crane technology for dam applications. Automation and remote monitoring. Cranes are increasingly being integrated with IoT, Internet of Things, sensors for real-time monitoring and predictive maintenance. Green technology integration. Efficient motors, regenerative braking, and solar power controls are being incorporated to reduce the environmental footprint. Smart safety systems. Advanced collision avoidance and obstacle detection systems are becoming standard, enhancing safety in complex operational zones. Modular and hybrid designs. Newer cranes are being built in modular formats, allowing easier assembly, transport, and upgrades. Hybrid electric-hydraulic systems also offer better performance. Conclusion. Gantry cranes are indispensable tools in the construction, operation, and maintenance of dam infrastructure. Their ability to lift and move heavy equipment with precision, even in harsh environmental conditions, makes them uniquely suited for these applications. From installing turbines and gates to facilitating emergency repairs, gantry cranes serve as the backbone of heavy-duty material handling at dam sites. With advancements in technology and growing demands for efficiency and safety, the design and operation of gantry cranes continue to evolve, ensuring their relevance in modern hydroelectric and water control systems.